So, as an example of how we might do calculations involving Avogadro's number, shown here is a particular number of grams of some substance. But of course, those number of grams corresponds to some number of moles of that particular substance. And we then would like to know how that's related to the number of particles. The most common approach for dealing with this would be dimensional analysis, but conceptually we can use the molar masses of a substance to convert between grams and moles, and we can use Avogadro's number because we would have 6.02 times 10 to the 23rd formulas or particles or atoms for every 1 mole of that particular substance. So if I have the grams of a particular substance, I would divide by the molar mass. That would then result in the number of moles. If I then wanted to go further to figure out how many particles or molecules or atoms that I have, I would take the result of that calculation and then multiply by Avogadro's number to end up with the final result. As an example of the reverse process, we would, if we are given the number of particles, then what we're going to need to do is use our conversion factor of Avogadro's number, and we're going to divide. This will give us the moles. And then if we take and use the molar mass, we can multiply by the molar mass to get to the grams. As an example of how to do this type of calculation, we have a question that states, what is the mass of a sodium atom to 4 significant digits? The given in this problem is the number of particles, or the sodium atom. And so in this particular case then, we would want to take and initially divide by Avogadro's number as a conversion factor, and then multiply by the molar mass. So we start with 1 sodium atom. We now need a conversion factor that's going to cancel the sodium atoms as a unit, and so we use Avogadro's number. In our conversion factor, the sodium atom is in the denominator. That then requires that the mole of sodium atoms is in the numerator. The next step is a conversion factor, which is the molar mass. In this case, since in the first conversion factor we have moles of sodium, now in our second conversion factor we need to have the mole of sodium in the denominator. This puts the grams of sodium in the numerator. If we then cancel the units that are both in the numerator and the denominator, we can then do the mathematics in our calculator. This gives us a value with quite a number of significant digits. Recognize that the question asks us to limit this to 4 significant digits. The 3, the 8, the 1, and the 7 will be the significant digits. But notice that the first insignificant digit, which is a 6, is greater than 5. We need to round the 7 up to an 8. This gives us a final answer of 3.818 times 10 to the negative 23 grams per sodium atom. As another example of a calculation that can be done using dimensional analysis, we have a question that asks, analysis of a solution of hydrogen peroxide, the formula being H2O2 for hydrogen peroxide, shows that it contains 0.909 moles of H2O2 in 1.00 liters of solution. What is the mass of hydrogen peroxide in this volume of solution? Well, the given that we need to start with here is the 0.909 moles of hydrogen peroxide, And since we have a conversion factor, which is going to convert between moles and the goal of the question, which is mass, that needs to be the molar mass of the compound. So this is not a given in the problem, but it's something that we could calculate as long as we know the formula. So in this particular case, we are going to look at the periodic table, multiply the atomic mass of hydrogen by 2, and add that to 2 times the atomic mass of oxygen. Putting this in the calculator, and we get a result which is 34.014 grams for every 1 mole. So at this stage, then, we're going to start with the given of the number of moles of hydrogen peroxide, and we're going to use a conversion factor, which is the 34.014 grams for every 1 mole. In our conversion factor, we want the moles to be in the denominator so that they cancel with the mole in the given. And at this stage, if we cancel, we see that the remaining unit is in grams. That was what the goal of the question was. So we don't need to do any additional steps. We can do the math by putting things in the calculator. Recognize that 0.909 moles is close to 1 mole, so I'm expecting an answer that is going to be slightly less than the 34. In this particular case, there were 3 significant digits in the given number of moles, the 9, the 0, and the 9. So we need 3 sig figs in our answer. The 9 to the right of the decimal point is the least significant digit. The first insignificant digit is less than 5, so we don't round it up. And so our ultimate answer is 30.9 grams of hydrogen peroxide, making sure that we've written down both the value, the unit, and the formula of the compound. As an example of the reverse process, when we are given the grams, we would also use the molar mass to determine the number of moles. In this question, how many moles of nitric acid are there in 28.5 grams of the material? The given is the 28.5 grams. Our conversion factor is going to be the molar mass. We need to calculate that molar mass from the formula. In this case, there's 1 hydrogen times its atomic mass from the periodic table, 1 nitrogen times its atomic mass, which is 14.007, and 3 oxygens times its atomic mass of 15.999. Add those all together, you get a total molar mass of 63.012 grams per mole. This will be our conversion factor. We start with the 28.5 grams given in the problem. We're going to multiply by the conversion factor that is going to cause the grams to cancel, so the grams need to be in the denominator. In this case, then, if we cancel the units, both the grams and the formula of the compound, we then can do the math, making sure that we have 3 significant digits, since 28.5 has 3 sig figs. Therefore, our final answer is going to only have 3 significant digits. No rounding is necessary, and we have 0.452 moles of nitric acid. As a final example, we have a question that is going to involve a unit conversion. In this case, the question asks, hydrogen cyanide is a highly poisonous gas with an average toxic dose of just 56 milligrams. How many molecules are in this mass of hydrogen cyanide? So, the given in this particular problem is the 56 milligrams. In this particular situation, we are going to initially need to convert the milligrams to grams, because our conversion factor of molar mass will be in the grams per mole. And then we can use that to do our conversion to moles. And then we can use Avogadro's number to convert the moles to molecules. So, starting with 56 milligrams of HCN, we know that the prefix milli is the same as 10 exponent negative 3. So, in our conversion factor, we put the mg in the denominator. In the numerator, we're replacing the lowercase m prefix with the equivalent power of 10 exponent negative 3. And then we cancel our unit of mg. The next step will be to convert from grams to moles using the molar mass. The molar mass is again calculated by summing together the atomic masses of hydrogen, carbon, and nitrogen. Cancel the units. Then finally we need the conversion factor from moles to molecules. This is Avogadro's number. And we multiply by Avogadro's number so that the moles of HCN cancel. And then at this stage we have arrived at the unit and the formula of what the goal of the question was. So that means we can then go ahead and plug everything into the calculator, multiplying everything that is in the numerator and divide by everything in the denominator. We can come up with a rough estimate of the order of magnitude we should be expecting, because we see that 56 divided by 27, I would estimate that as being 25. 56 divided by 27 is about 2. 2 times 10 to the negative 3, and then 2 times 6 is 12. And then we have times 10 to the 23rd. So I'm expecting something that'll be about 12 times 10 to the 20th. And so in fact that is the same as 1.2 times 10 to the 21st. And of course we need to account for the significant digits. In this case there are only 2 sig figs in the given from the problem. So we need to limit our sig figs to the 10th place, no rounding involved.